Okay, so we'll have a look at frequency distribution. So we'll need to just cover some vocabulary first. Does anybody know this word, tally? I'm using it here as a verb.
Count?
Yeah. Tally means count. But it means count usually it means count in a certain way. Does anybody know which way? Yes, it's like this. It means count like this, which you've all seen on TV. Prism, that's what everyone always thinks of, yeah. And I don't remember, but there is some Chinese one, isn't it, where it goes, oh, something this, and then there's a this thing here and a this thing here or something. I don't remember it. But I know the Chinese one of this looks different. Yeah, but you've seen this one. Yeah. So in the West we have a simpler one. The Chinese one I know looks nicer though. Which way does it go, the Chinese one? What do I draw first? Horizontal? Vertical? I know, so it goes 1, 2. Okay, so 1, 2, and then there's one here. 3. Down here? Here? This is the left. Like this? And then the last one? Here? 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 Oh, same as the top. Oh, I see. So it goes 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'll do one more for practice now. 1, 2, 3, 4, 5. Perfect. Now tell me, does each one have a name? Like, is this the Chinese for 1 or something, or does this mean anything? Isn't like this is 1, 2, and 3 in Chinese, isn't it? Yeah. So that's different to this. 1, 2, 3, 4, 5. I think I'll stick to this one though. Okay. So if you're not using this, you're using this. But both everywhere in the world has a tally system, and it counts up in 5s. So for the question here, when I say tally, it means make one of these diagrams. So for example, the first one here, here, I'll make my own example. So if I just have some grades, like A, B, C, B, C, A, B. If I want to tally these, I could have A's, B's, or C's. So let's see, I have 1, 2, 1 here, 1 here, 1 here, 1 here, 1, and then here. Better stick in another A to make it interesting. Like this. So this will be a tally the grades. Oops. And we usually actually write the number as well here. 5, 3, and 2. So, of our 4 types of data, ordinal, nominal, continuous, discrete, what could I use a tally for? Discrete, yeah. Quantitative discrete, I could use a tally. Could I use it on ordinal? I could. In fact, this is ordinal. A, B, C, D grades are ordinal. What about on nominal? Something like eye color. I could, yeah. Blue, brown, whatever. So the only thing that this is not suitable for is continuous. It's not suitable for. So this is not suitable for continuous. Now, next, so that's a tally. Next we have a frequency table, or sometimes called a frequency distribution. And frequency distribution table, you've used them all the time in biology, chemistry, and physics. It's just, you may not have called it a frequency table. I don't know, you can tell me if you did. So it's just a table whereby on the top is your data, and then on the bottom is your frequency. And frequency just means how much you have. A grade, B grade, C grade. So in this example here, how many A's? 5. B, 3, and C, 2. That's all a frequency table is. I'm sure you had one of these in one of your lab reports maybe. Which one? The equipment? Yeah. How much? Yeah, so for nominal data like equipment list, you would have 1 heart, 2 knives, well not knives, scalpels, whatever. Yeah. So again, frequency table is something very simple there, and it's suitable for ordinal, like this one, nominal, and discrete. And it's not suitable for continuous.
It's like the tally.
It's pretty much the same as a tally. I mean, it's practically the same thing. In fact, the tally is a little bit better because the tally has a nice picture form as well. Okay, so now we've talked about tally and frequency table, and in both cases we said this is not suitable for, these are not suitable for continuous data. So we need to have a look at continuous and how we can count continuous data. And we can count continuous data using something called a grouped frequency table or distribution. So I need to have some continuous data. So I know, we'll use something like your enzyme activity. So you measure this in centimeter cubed. What type of numbers were you getting? Something like 20, 21, in the 20s? 40s? What was the biggest number you got? You went as high as 70? And the smallest?
0.
You have zeros?
Yeah.
You did? Okay, so I'll just pick some numbers from 0 to 70. So let's say you have like 0. What happened? You added more, the temperature, wasn't it? You changed the temperature. So the first time you did, you had 0.
No, last time.
Last time you had 0, okay. So what type of number did you have first? Around 30, okay. And then what happened? Did it increase or decrease? Increase or decrease?
From 30 to 0, because the temperature is coming to the temperature, vaccine.
Okay.
They have an optimum temperature.
So it increased and decreased?
Yeah.
So 30, 34.1, 36.2, 38.3, 40, I'm just making up my own one here, 37.2, 30.1, let's say it starts to crash down now as it heats up. 20.2, 10, and 0. Something like this. And these are all in centimeters cubed. Now, it would be inappropriate to count up how many 1 centimeter cubes I have, how many 2 centimeter cubes I have. Why would it be inappropriate to do this? Why would it be inappropriate? Why would it be wrong to do this? Why would it be wrong to have a table that looks like this? Here I have 0 centimeters cubed, 1 centimeter cubed, 2 centimeters cubed. Yeah, where would this table stop? How far would I need to go? Well, if I look at this data here, how far? I need to go to 40, wouldn't I? So it would mean that my table is bigger than my data, which is ridiculous. And also, I don't have 1 or 2. I mean, I would have a 10, but what do I do with this one? Maybe I put it in 20, maybe I put it in 21. So anyways, we can see why it's inappropriate to use a frequency table. Instead, what we have to use is a group frequency table, which means...
Like the numbers between 30 and 40 together?
Yes. We put them in between 2 ranges. So this is my volume here, and then this is how many I have. Now, there is a problem though. Did you do something like this in biology? Did you put in a grouped table? And what I mean by group is maybe the first one is 0 to 10. No, how did you present your data?
No. It was not this way, it was calculating all.
Oh yeah, but you still needed to record your data and put in your report, right? So how did you present your data in your report?
Temperature and the
Was it in a table?
Yeah.
And what did the table look like? Was it just a list of all the points?
Yeah, the list of all the temperatures we're going to have.
Okay. And that's fine if you have a small sample like this of 10 or 20. But if you did this experiment or you had like 100, it wouldn't be suitable to have a table that's 100 rows long. So the first thing we want to know is how many boxes should we have here?
0 to 10.
Well, there's different ways. First, how many data points do we have? So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my rule. I mean, it's what's used by a lot of computer programs as well. You count up how much data you have. So in this case, it's 10. And you take the square root of 10. What's the square root of 10? 3 point something. Can you check it actually? 3.2 maybe? 3.16. So 3.2. And you round this number up. So if I round this number up, what do I get?
3.
Round up. Up 4. Yeah, so I make my table have 4 boxes. Now this, by the way, listen, this is not a rule. This is just a guideline. If you made your table have 5 boxes, that's okay too. I'm just saying, if you need some guide to know how big to make your table, one rule I've seen is it should be the square root of how much data you have rounded up. So here, square root of 10 is 3.2. If I round that up, that's 4. You don't want too many boxes, and you don't want too few boxes. I think we all agree that if I only had 2, that would be unsuitable. Right? It's not enough, isn't it? What about if I only had 1 box? 0 to 40, 10 of them. This is ridiculous, isn't it? And then what about if I had 30 boxes or 40 boxes? Yeah, there's too many. A lot of these boxes will be 0. So a suitable number here would be 4. Okay, now next we need to know what is the biggest and what is the smallest number. So what is the biggest number here? 40. And the smallest? 0. So we know we're going to start at 0 and we're going to finish at 40. So if we do 40 divided by 4, because there's 4 boxes, what's that? 10. So we must go up in tens. So 0 to 10, 11 to 20, 21 to 30, 31 to 40. Okay, the 0 to 10 box, let's see what's in that. So of course we have 0 here. Let's see, let me just get rid of that circle for the moment. We have 10. Anything else? No. So that's 2 goes in there. Okay, now 11 to 20.
0.
11 to 20. Do we have none of those? No.
20.2 is going to be rounded up to 21.
Yeah, now which box does this go into?
20.2?
It actually goes in this one. Because 20.2 is closer to 20 than it is to 21. So it goes into this box. So is it just one? 30.1 would all go into this box.
Yeah, 30 and 30 was also both of them going there.
Into this box. I'm still talking about this one. It's just one. Okay, now 21 to 30. So that's 1. No. Yes. True. And finally 30 to 40 or 31 to 40. 1, 2, 3, 4, 5. So you notice that there was some problem here because it's not clear exactly what's happening when I have 10.6 or 10.2. Does it go in here or here? So normally always what we need to do for the exam is write down something called the boundaries. The boundary, the lower and the upper boundary. By the way, I've been calling these boxes, but that's not really the technical name. What do you think? Cell? Very good. I would be happy with cell, but cell is a very it's like a very much a Microsoft term. But I'm happy with cell. In most maths books they call them classes. Yeah. Although I do like cell here, I would use cell. Anyways, each class has a boundary, a lower boundary and an upper boundary. The biggest number, the boundary up here is between the 10 and 11. So if I write the boundary underneath, the boundary here is 10.5. You must be smaller than 10.5 to be in this box. And 0 here. In this box here, if you're bigger than 10.5, you go into it, don't you?
So 10 to 10, 10 to 20, 20, 30.
Here? What are we talking about here or here?
He said instead of the 11.
Oh, no. The top or the bottom? Yeah, you could do 0 to 10, 10 to 20. That's fine. And that's kind of what I'm doing here. Right now it's not clear, so now we need to make it clear. So I'm going 0 to 10.5. And then this one here would be 20.5. I need to make a bit more space. Let me just put my boxes down a bit more here. So this one here is called the boundary. So here is 0 to 10.5. Here, so this is like what you're saying, Yusra, 10.5 to 20.5. And here, 20.5 to 30.5. And here, 30.5 to 40. Or 40.5. We can just say 40 here. Because we know there's nothing more than 40. Now, if you want to make this really, really clear, you can put it in your sets. So here, it's 0 to 10.5. But you don't include the 10.5, because when you have 10.5, what happens to this number? It rounds up to 11, which puts it in the next box. So this next box is actually 10.5 to 20.5. Do you see what I'm doing? I'm making the sets like we did in semester 1. This one here is 20.5 to 30.5, 30.5 to 40. And we can actually include the 40 here at the end. Or if you don't like that, if you want to stick to your 0.5s, you can, there's no problem. We could do 40.5 and then open. So now it is perfectly clear where each number goes. So if I said 20.5, which class does that go into?
Class 3.
Yes. If I said 30?
30, class 3.
Class 3 also. 0?
Class 1.
Class 1. 40.1? Class 4. So when we write it like this, with the lower and the upper boundaries, it's very clear. This one is called the lower boundary, and this one's called the upper boundary. Lower, upper, lower, upper, lower, upper. And please note, absolutely these numbers must be the same. Because if they're not the same, it means you have a small gap. Your data is not nice and lined up. There's pieces missing. So these are called the class boundary. Well, I just already wrote it there. Let me just stick the word class there. Class boundary. Now, each class also has a midpoint. No surprises and no prizes for guessing what the midpoint is here. So if I had 0 to 10.5, what's the midpoint here? It will be 5.25, yeah. And here 10.5 to 20.5 is 15.5. 25.5, 35.5. So these are the midpoints of each class. Okay, next now. The last thing we want to know is the range of each class. Does anybody know what the range is for a class here?
0 to 10.5.
Say again? Yeah, it's the highest minus the lowest. In other words, it's the upper minus the lower. So here the range would be 10.5. Here what would the range be? 10. 10 and 10. Notice, we don't really worry too much that they're not all the same. In fact, this is not really a problem in maths. It's nice when they're all exactly the same. And if you want, you can make them all the same. You can make this 0. You'd have to make it a minus 0.5 if you want it to be the same. But I mean, it's not really an issue here. And in fact, when you do histograms, which I know you've done with columns, There's definitely no problem with a histogram if the bars are different widths. This is not a problem. So it's not something to worry about here. Okay. In the exam, often the question in section B, they give you this grouped frequency table and then they would ask you for the boundary and the midpoint.
This is the
Section B question, yeah. Yeah, it'd be the start of the section B question. So, sometimes the question says, copy your table into your answer book and include a class boundary, or include the midpoint. I should point out, in the exam, they always write their tables going vertically, so in the exam this table would actually be written like this, 0 to 10, 2, 11 to 20, and this is volume, and this is frequency, 11 to 20, 21 to 30, 31 to 40, 2, 1, 2, 5. That's how it will look in the exam. So they always write like this. It's better use of space. Because in fact the table is usually quite big. It will be normal for this to have 10 to 12 rows. So if you do 10 to 12 horizontally, it's too long. So they do it vertically, which is no problem. Just don't be confused by that, okay? Alright, so not too difficult, just practicing some basics here. And yeah, you've got a few minutes to try a couple. So try these now, please.